Now, after the functions and the graphical part, let's move to the next thing, that is progressions, in which the AP and GP are important, arithmetic progression series and the geometric progression series. So we'll start with the first case, arithmetic progression. Now, in case of AP, what is the definition of AP? We can say that any series will form an AP if the difference between the two consecutive terms will remain same. For example, I can say if the first term is A, the second term will be A plus D, the third term will be A plus 2D, and so on. Now, the different things in related with the AP, the first important thing is that the nth term of any arithmetic progression is always equal to A plus n minus 1 into D. Okay. Because for second term we are getting D, for third term we are getting 3 minus 1, which is 2D. Now, nth term is this one, and the next thing is what is the sum of n terms. Now remember that the sum of n terms of an arithmetic progression series is n by 2 into first term plus last term, which in turn is nothing but Sn is equal to n by 2 into 2a plus n minus 1 into d. So basically these are the three important formulas when we are discussing the arithmetic progression series. Let's take a couple of questions based on the arithmetic progression. For example, if I say that 7 times 7th term of an arithmetic progression is equal to 11 times 11th term of an arithmetic progression, then which term is equal to 0? I repeat once again, 7 times 7th term of an AP is equal to 11 times 11th term of an AP, then which term is equal to 0? So remember that in all such type of questions, straight away put the values, use the formula straight away. Can I write down that 7th term is basically nothing but I can write down this as A plus 6D, and 11th term is nothing but that will be 11 into A plus 10D. Okay. Now here what will I get? That is 7A plus 42D is equal to 11A plus 110D, and if I take out that term here, I'll get the value as 4A plus 110 minus 42 68 is equal to 0. Now 4A plus 68 is equal to 0, which means nothing but that is 4 into A plus 17D equal to 0. Now which means A plus 17D equal to 0. Now A plus 17D equal to 0, it means that is nothing but T18, 18 term, because 18 term will be A plus 17D. So here we can say that if 7 times 7 times 7th term is equal to 11 times 11th term, then in that case 18th term is always equal to 0, which is T18. Similarly, if I say, let's say there are two different arithmetic progression series. This is the first AP, I'll represent it by AP1. This AP1 is starting from, let's say if I say 4, then the next term is 8, the next term is 12, the next term is 16, and so on. Let's say another arithmetic progression series which is AP2. Now this AP2 is nothing but it starts from 5, then 10, and then 15, and so on. And we need to find out the sum of first 100 terms which is common in both the series. I repeat once again, we need to find out the sum of first 100 terms which is common in both the series. So just see how. If I look at here the value is increasing at a gap of 4, 4. That is 4 plus 4, 8, 8 plus 4, 12, 12 plus 4 is 16, 16 plus 4 is 20, 20 plus 4 is 24, and so on. And here 5, 10, 15, next term will be 20, and next term will be 25. So the first term which is common in both the series is 20. Now the point is, which is the next term which is common here? Now here the value is increasing at a gap of 4, and here the value is increasing at a gap of 5. And we have to find out the common term. So the common term is nothing, but that will be always at the gap of the LCM of 4 and 5, which is 20. So once I find out that the common term is 20, the first term is 20, the next common term will be 40. And next common term will be 60 and 80 and so on. Okay. So the again the important thing is that the common difference between this series is nothing but that is always the LCM of 4 and 5, which is 20 here. Now we are supposed to find out the sum of first 100 terms. The straight away sum of first 100 terms is equal to n by 2, 100 by 2 into 2a, 2 into 20 plus n minus 1, which is 100 minus 1 into d, which is 20. And from here we can find out what is the sum of the first 100 terms of this series. Now, another important thing in case of arithmetic progression, if I say, let's say there are two different arithmetic progression. Okay.